Hello students and welcome back to the channel Learn for Dreams. Learn with fun, say goodbye to boredom. Today we will see what is clipping and algorithms used for clipping. So let's start with the definition. Clipping is the process of determining the portion of the geometric model outside the window and making that portion invisible. Now let's take an example. Here in this picture, left one is a complete object and right one is just a small part of a complete object. यहाँ देखो इस white window के बाहर वाला part invisible कर दिया गया है और सिर्फ window के अंदर वाला part visible रखा गया है. Okay? This is called as clipping. Now let's see what are the conditions used for clipping. In clipping, each graphic element is examined to determine whether or not, first condition is, element is completely inside the window, then that element is to be drawn completely. If element is completely outside the window, then the command given is don't draw the complete element. And if the element crosses a window boundary, then the command given is draw the only portion inside the window. Now let's see which are the clipping algorithms. There are two algorithms used, Cohen-Sutherland algorithm and Sutherland-Hodman algorithm. Now clipping algorithms are used for point clipping and line clipping. Let's see point clipping algorithms. This is an entire screen and this is a selected window. These are boundary limits x minimum, x maximum, y minimum and y maximum. These are the points at various locations. These are four inequalities. X minimum should be less than and equal to x, x maximum should be greater than and equal to x, y minimum should be less than and equal to y, and y maximum should be greater than or equal to y. If any of these four inequalities is not satisfied, the point P xy is clipped. It means it will be invisible. Now let's see Cohen-Sutherland line clipping algorithm. Suppose this is a selected window with boundary limitations x minimum, x maximum, y minimum and y maximum. This is boundary 1 or beat 1. This is boundary 2 or beat 2. This is boundary 3 or beat 3. This is boundary 4 or beat 4. This is line with endpoints P1, X1, Y1 and P2, X2, Y2. This is a 4-bit representation for each point. Beat values are considered from right to left. Always remember. Now let's see beat representation for various regions. Beat representation for window is 0, 0, 0, 0 because window is considered as a center point. Always remember this table. Beat 1 is for left side of the window. Beat 2 is for right side of the window. Beat 3 is for the region below the window. And last bit, that is beat 4, is for the region above the window. Now let's see beat representation for the regions. This region is on the left side of the window, so only beat 1 value will be 1. All other beat values will be 0. So the beat representation for the region becomes 0, 0, 0, 1. Now let's take the next region. This region is on the right side of the window, so only beat 2 value will be 1. All other beat values will be 0. So the beat representation for the region becomes 0, 0, 1, 0. Now for the next region, as it is below the window, only beat 3 value will be 1 and all other beat values will be 0. The beat representation for the region becomes 0, 1, 0, 0. Similarly, this region is above the window, hence beat 4 value will be 1, all other beat values will be 0. The beat representation for the region becomes 1, 0, 0, 0. Okay? Now let's see for remaining regions. which are combinations of two bit values. Let's consider this region which is on the left of the window as well as above the window. So bit values for bit 1 and bit 4 becomes 1 and bit 2 and 3 is 0. Hence the bit representation for this region becomes 1001. Now similarly for this region which is on the left of the window as well as below the window, so bit values for bit 1 and bit 3 becomes 1 and bit 2 and bit 4 becomes 0. So this region is represented as 0101. Similarly, this region is on the right of the window as well as above the window, so bit 2 and bit 4 becomes 1 and bit representation for the region is 1010. Now for the last region which is on the right as well as below the window, so bit 2 and bit 3 values becomes 1 and bit representation for the region is 0110. So this is bit representation for all the regions. Is it clear? If you have any doubt, you can ask in the comment section. Now let's see how to decide whether the clipping is required or not. Consider the line P1, P2. Both the points are inside the window. Hence bit representation for both points is 0000 and 0000 for both P1 and P2. If I apply AND condition between P1 and P2, it will be a bitwise operation. The value becomes 1 only when both bit values are 1. So here we will get P1 and P2 is equal to 0000. It means no clipping is required. The entire line is inside the window. Now let's consider line P3 and P4. Point P3 and P4 lies in the same region whose bit code is 0001. If I apply bitwise AND condition between P3 P4, as I have value 1 for same bit for P3 and P4, the bit code for P3 and P4 is 0001. It means line is completely outside the window. So no clipping is required. Now consider line P5 P6. For point P5 bit code is 0000 and for point P6 bit code is 1000. Now if I apply bitwise AND condition between point P5 and P6, I get bit code as 0000 as point P5 is inside the window and P6 is outside the window and final code is 0000. The clipping is required. Now consider line P7 P8. The bit code for P7 is 0100 and bit code for P8 is 0010. If I apply AND between P7 and P8, it gives bit code as 0000. Here both points P7 and P8 are outside the window, but the final bit code after AND condition is 0000. It indicates that the clipping is required. Okay. So this was all about Cohen-Sutherland line clipping algorithm. Hope you enjoy learning. If you find this video informative, please hit the like button and share it with your friends. Also subscribe to the channel Learn for Dreams and don't forget to hit the bell icon.